This is the start of guided exercise number 3. We are working still with the Seattle housing data, and we'll pick up from guided exercise number 2, where we focused on univariate analysis or looking at one variable by itself. So to review the data mining steps, our business understanding for this problem is to build a model that will predict selling price. From a technical perspective, we're going to be building a predictive model. In step 2, we have our data, and we have begun to explore each individual variable by itself. In guided exercise number 2, we reviewed how to do each of these bullets, these different points. And now we're going to be moving into this bivariate analysis. The goal here is to begin to explore the data and the predictor variables as they relate to the outcome variable. So we want to see, for example, how square foot living is related to price. So logically, we know that it's going to be a positive relationship. As square feet living increases, price will also increase. But there may be other variables that we're not so sure, and we just want to sort of document and get different measures on what that relationship, what the relationships are between each predictor variable and the outcome variable. When we establish that there is a relationship with the outcome variable, then we can use that predictor in building our model. And in this case, we'll be building a regression model later on. I also want to show you how this relates to the CRISP-DM methodology and where we are in the process. So the data mining steps is just, again, an abridged version and sort of a step-by-step guide to going through these CRISP-DM steps, which are a little more detailed. But again, I just wanted to show you where we are in relation to that manual. Okay, now we're going to get ready to work again with our Seattle housing data. And what I'd like you to do is, from the file that you've been working in, go ahead and save it as a different file. And then we're going to make a fresh copy of the original data. So here we have the Excel worksheet that we were working in with guided exercise number 1 and number 2. And I've gone ahead and saved this as a new file called guided exercise number 3. What I want to do is make a fresh copy to work from, a fresh copy of the data. So I'll go to my original data here and make a copy. So I'm going to move a copy, create a copy, move to end, okay. And now I'm just going to give it another color. This time we'll go with some sort of green. Now, if you want, you can delete these old tabs, or you can just hide them. So let's click on histogram of price, click on this. I'm going to right click, and I'm just going to hide these sheets. Okay. Also, what I want to do is, for simplicity, I just want to delete out zip code, latitude, and longitude. It's just going to keep things simple in Excel, but I know that I have a copy of the original data, so I'm not too worried. So I select these, and I'm just going to delete. And now we are ready to move on. So we're ready to start the bivariate analysis. And again, the goal here is to study the relationship between the outcome variable and predictor variable, and to identify some strong relationships because our ultimate goal is to predict price. So we're starting on the data mining steps, and we are on 2.3D1, small Roman numeral 1, and that is here on the data mining steps. We're going to create a correlation matrix of all numerical data and figure out which variables are strongly correlated, which variables have a strong linear relationship with price. Okay, so let's get started with making a correlation matrix, which is going to be, correlation is a measure of linear relationship between two numerical variables. So we'll make the correlation matrix and then we'll talk about what the numbers actually mean. So when we look at our data and our variables, they need to be numerical. In Excel, if you try to select text data or categorical data or even date data, you're going to get an error. So keep in mind that correlation, running the correlation in Excel, you always need numerical data. In the slides, I have a step-by-step of how to do the correlation matrix, but right now we're going to go ahead and do it in the video. So to make this correlation matrix, we are going to go to the Data tab and select Data Analysis. From this menu, we're going to choose Correlation here, okay? And now we have this dialog box. Our input range will be all of the numerical variables that we want to get the correlation on. So I'm going to select everything. I'm doing Shift right arrow. Now I'm going to do Shift Control down arrow, and that will give me all of the data. Notice that I have not included the first two columns as those aren't of interest to me. So I do have labels in the first row. I'm going to go ahead and put this on a new worksheet. I'm going to hit OK, and Excel generates this output. So the correlation matrix gives us a correlation coefficient for each pair of variables. For example, the correlation between bedrooms and price is 0.308. The correlation between, say, waterfront and floors is 0.023, 0.24. So let's talk a little bit about what those numbers mean. So a correlation coefficient, sometimes it's called a Pearson correlation coefficient, is always going to be a number between -1 and 1. If it falls outside of those numbers, it's incorrect. So it's always between -1 and 1. And the closer the value is to the extremes, to -1 or 1, the stronger the linear relationship is between two variables. So a positive correlation coefficient means that the two variables have a positive relationship. That means as one increases, the other increases as well. A negative relationship means as one increases, the other decreases. So here, for example, we say that the correlation between grade and price is 0.667. So that means there's a strong or moderately strong linear relationship between grade and price. As the grade score or measure increases, the price tends to increase as well. If the correlation coefficient is close to 0, then we would say there's no relationship between those two variables. For example, we can see that waterfront and number of bedrooms, while it has a negative relationship, it's so close to 0, we say that essentially there's no relationship. Same with view and bedrooms, 0.07, 0.08, but essentially this is close to 0, and we say there's no relationship. So let's look at this negative correlation coefficient between square feet in the basement, and floors. So this says that there's a weak negative relationship, meaning that the higher the floors, so the more floors there are, square feet basement decreases. Okay, so again, that is, the relationship tends to be that when there are more floors in a house, there is less square footage in the basement. So that's how a negative relationship works. We can understand what a correlation coefficient is measuring by looking at scatter plots of two variables, one plotted on the x, one plotted on the y axis. Here in this slide, I have a few links and a few extra pieces of information on correlation coefficients. And you can see here a perfect negative relationship. Here is a negative correlation between these two variables. Note that this little p is it's a lowercase Greek r, or rho, and uh, that is a symbol, a notation, sorry, for um, correlation coefficient. These scatter plots gives you an idea of what correlation coefficient is measuring. Also, remember that correlation coefficients do not measure any relationship, only a linear relationship. So in this circled scatter plot, my data could look like this, sort of U-shaped, but the correlation coefficient would come out to 0 or something close there, close to it. So we would have to find another way to measure this relationship and represent this relationship. Finally, most importantly, remember that correlation does not prove causation. It is just a formula that data is put into and a number is calculated. So we know what it measures, but it always has to be verified with some sort of scatter plot to make sure. The next thing we want to do to enhance our correlation matrix is to put some conditional formatting on it. So what we're going to use is this option once we have the whole matrix selected, and our result will be something like this, where the stronger correlations will pop out and be easily seen. So a stronger correlation is here, here. Again, these are strong positives. They're close to 1. The closer to 1, the stronger the relationship. And when we go to analyze this, we're going to primarily be looking at which variables have the strongest relationship to price, because we'll be able to use these to predict a future value of price based on the characteristics or the data on these variables. So to get this formatted correlation matrix, I have the whole matrix selected. I'm going to go to the Home tab and then Conditional Formatting, and I'm going to do color scales. You can choose a color scale here. Any of these, whichever is your preference. I tend to like the red, white, and blue, so I'm going to click on this, and it will conditionally format everything for me. Now keep in mind that the conditional formatting is based on, the colors are based on a scale that is from the minimum to the maximum. So if I look for my minimum, that is negative 0.36, and my maximum will be a 0.87 here. Everything else is scaled in between. So it's just important to keep in mind that the color scheming is going to be based on the minimum and the maximum value in the selected data.